Unit 2. Light Energy. Lesson 1. Mirrors. What's meant by light reflection? It is the phenomenon of light bouncing off in the same direction when it meets a reflecting surface. First law of light reflection. First law of light reflection states that angle of incidence is equal to angle of reflection. If we have a plane mirror and we have an incident light ray, it will reflect back in the same medium. And if we draw the perpendicular from the point of incidence, we will have two angles. The first angle is the angle between the incident light ray and the normal, which is called the angle of incidence. And the second angle is between the normal and the reflected light ray, which is called the angle of reflection. And as the first law of light reflection states, the angle of incidence is always equal to the angle of reflection. We have an important question here. Give reasons for the perpendicular incident light ray on a plane mirror reflects on itself. Because the angle of incidence is equal to the angle of reflection, which equals 0. We have a drawing that explains this question. If we have a plane mirror and the incident light ray is falling perpendicular on the plane mirror, it will reflect on itself with an angle equal 0. Second law of light reflection. Second law of light reflection states that the incident light ray, the reflected light ray, and the normal to the surface of reflection at the point of incidence all lie in one plane perpendicular to the reflecting surface. Types of mirrors. We have two types of mirrors: plane mirrors and spherical mirrors. Concerning spherical mirrors, we have two types of spherical mirrors. The first type is concave mirror. The second type is convex mirror. We will talk about the image formed by concave mirror first. The image formed by concave mirror depends on the position of the object in front of the mirror. As we will see later, the position of and the properties of the image depends on the position of the object in front of the concave mirror. We will draw different images according to the position of the object concerning the concave mirror. Our first drawing will be for an object which is located beyond F and C, more than double the focal length. If we have a concave mirror, and this is the principal axis which passes through its center of curvature and its pole, and the object is after C. To draw the image formed by the concave mirror for this object, we have to draw two light rays. The first light ray will be parallel to the principal axis, and it will reflect passing through the focus. The second ray will pass through the focus, and it will be reflected parallel to the principal axis. The intersection point between the two reflected rays will be the position of the image. As you can see, the location of the image is at a distance which is more than the focal length and less than double the focal length. What about the properties of the image? As you can see, the image formed is real, which means that we can receive it on the screen. inverted, and small or minimized because it seems smaller than the object. The second drawing is for an object which is located at the center of curvature of the mirror. Again, this object is located in front of the concave mirror, and we will draw the principal axis. If you are interested in drawing this concave mirror by using a compass, I suggest that you open your compass at a radius which is equal to 6 centimeters. This is the center of mirror curvature, and this is its focus, and this is the pole of the mirror. The object is located at the center. As usual, we will draw two rays. The first one is parallel to the principal axis, which will be reflected passing through the focus, and the other ray will pass through the focus, which will be reflected parallel to the principal axis. The intersection point of the two reflected light rays will be the location of the image. As you can see, the image is formed at the center also, and the image is real, inverted, and equal to the object. And know that this is the only case in which you will be asked about the size of the image. For example, the question will be as follows. If the object is placed at the center of mirror curvature and the size of the object was 4 centimeters, what will be the size of the image? In this case, the size of the image is equal to the size of the object, and it will be equal to 4 centimeters also. The third drawing is for an object which is placed between C and F, or at a distance more than the focal length and less than double the focal length. As usual, we have the center of curvature, focus, pole of the mirror. The object is located between C and F. The first light ray is parallel to the principal axis, which will be reflected passing through the focus. The second light ray will pass through the focus, which will be reflected parallel to the principal axis. The point of intersection of the two reflected light rays will be the position of the image, and as you can see, the image is formed at a distance more than the radius of mirror curvature, or at a distance more than double the focal length. The properties of the image formed are real, inverted, and magnified, or enlarged. What about an object which is located at the focus? And this is a very special case. The object is located at the focus. As usual, we will draw the first light ray which is parallel to the principal axis, which will be reflected passing through the focus, and the second ray must pass through the focus, but it is impossible right now, so it will pass through the center of mirror curvature. And if we have a light ray which passes through the center of mirror curvature, it will be reflected on itself. As we can see, we have two parallel reflected light rays, so we don't have any point of intersection, so no image is formed, or we can say that the image is formed at infinity. So we don't have properties for this image because it is not formed. If the object is located between the focus and the pole of the mirror, we have the center of curvature, focus of the mirror, pole of the mirror, which is the midpoint, which is located in the mirror surface. The object is between focus and pole of the mirror. The first light ray will will be parallel to the principal axis. It will be reflected passing through the focus. The second light ray, we can't draw it passing through the focus, so we will connect it. It will pass through the center of mirror curvature and it will reflect on itself. As you can see, the two reflected light rays are not intersecting, so we will try to extend them from the other way. So we will have a point of intersection behind the mirror. This point of intersection of the extension of the reflected light rays will be the position of the image. The image is formed behind the mirror and the image is virtual. This means that it is not real. We can't receive it on a screen, and the image is erect or upright and magnified. It means that it is larger than the object. We will talk about the image formed by the other type of spherical mirrors, which is convex mirror. The image formed by convex mirror doesn't depend on the position of the object in front of the mirror. As we will see later, the position and the properties of the image is always virtual, erect, and small in size. Whatever the location of the object in front of the concave mirror, the image will be formed as follows. We will have a convex mirror. This is the center of mirror curvature, which is behind the reflecting surface of the mirror. And we have the focus and the pole of the mirror. The object will be in front of the reflecting surface of the mirror, which is the outer surface in case of convex mirror. We will draw the first light ray, which is parallel to the principal axis as usual. The convex mirror is a diverging mirror. It will separate light ray. So this light ray will be reflected away from the mirror, but its extension will pass through the focus. The second light ray will pass through the center of mirror curvature. It will reflect on itself. The point of intersection between the two reflected light rays, or the extension of the two reflected light rays, will be the image. And as you can see, the image is formed behind the mirror, and the image is virtual. It can't be received on a screen, erect or upright, and small or minimized. Thanks for watching. This was the first part from this tutorial. Goodbye.